Hey everyone, my name is Matheus,
And I am Guilherme.
and we are now presenting our project which is called Registration and Simulation of the Antiarrhythmic Effects of Narigine by Use of the Software PharmaLab. According to a study performed by the World Health Organization in 2021, the cardiovascular diseases represented the biggest cause of mortality and morbidity in the world in 2019, with roughly 18 million deaths registered, representing 32% of the global deaths in that year. By knowing that, it is important to study ways to decrease that death rate, and for sure, the study based on antiarrhythmic drugs gets a great relevance in that scenario and must be taken in consideration. Once established this study as a priority, it is necessary to discover ways to obtain those drugs and also discover how they would act in our organism. But it's difficult to test all of this in a practical way. So there's when enters the simulations, using softwares to those researchers. The cardiac action potential has 5 phases, 0 to 4, essential for heart function. Phase 0 involves rapid depolarization due to sodium influx, slowed by class 1 antiarrhythmic drugs. Phase 1 is brief repolarization from potassium influx. And Phase 2, a balance between calcium influx and potassium influx occurs with class 4 drugs reducing calcium entry and contractility. Phase 3 sees rapid repolarization from potassium influx prolonged by class 3 drugs. Phase 4 is the resting potential, where class 2 drugs, also known as beta blockers, slow the heart rate by reducing pacemaker activity. Each drug class targets specific phases to treat arrhythmias.
Methodology. There are many software used in simulations for the pharmacological research. Between them, we could cite APPredict and Manta. The one used for this research is PharmaLab, a software based on the 2013 Mullins and Bondarenko's mathematical model for mouse myocyte, developed by Leonardo Camargo. PharmaLab is capable of simulating mouse myocyte APs with and without drug application, and comparing both. It also provides data about imported ionic currents, as calcium and potassium currents, and variables like the AP50, the actual potential duration, which is the time that it takes for the cell potential decrease, from the peak of the AP down to the half. Apart from that, it allows registration of different drugs by informing the IC50 and Hill coefficient. IC50 is defined as the percentage of drug necessary to inhibit 50% of an ionic current, and Hill coefficient is the number that tells us how strong the drug affects the channel. The compound used for this research is a flavonoid called narigine. It is mainly extracted from grapes, Chinese herbs, and citric fruits, and has shown good antiarrhythmic properties, as presented by 2023's Lee's work, which will be the main source of experimental data for validation of the simulation results. The variables used for simulations are duration of pulse train, measured in milliseconds, which is the duration of the simulation, pulse train width in milliseconds, which is the width of each pulse train, stimulation frequency in hertz, which is the frequency of the application of pulses, stimulus current in picoampere by picofarad, which is the density, that is, how strong is the pulse applied, pulse train application time in milliseconds, that is the time when the first pulse train is applied, and finally, the initial sarcomere length and cell length, both measured in micrometer. The settings used are shown on the screen. These were repeated for 4 simulations in different concentrations, 100, 200, 400 and 800 micromolar, using IC50 equal to 508.5 micromolar and Hill coefficient equal to 1. From the simulations, we extracted the percentual inhibition for ICAL for all concentrations, plus the AP, APD50 and APD90 for 800 micromolar. Results. The results follow as below. The APs for simulation presented similarities with Lee's experiment, but a better comparison can be made by looking at the APDs. As we can see, the APD50 for the simulation were of 1.13% of the experimental range. However, the APD90 presented a good result, fitting the experimental range. For the percentual inhibition of ICAL, we see that the simulation presented the best result for the 800 micromolar, with lower concentrations showing less precise results. Conclusion. In conclusion, the software shows the potential for predicting the action of antiarrhythmics, but the lack of precision in some cases might depict an opportunity of improvement in the software or in the parameters used. Apart from that, it highlights the antiarrhythmic properties of narigine and the importance of simulation for research.